Okay, this next one, I need to go ahead and get my x squared by itself. So what I'm going to have is I need everything on the left-hand side. So I'm going to need to subtract 6x from both sides. So by subtracting 6x, I'll have a minus 6x on this side. It's still a plus 13. And then on the other side, 6x minus 6x will be 0. So everything is on the left side again. If I was going to try to graph it, I can go to Desmos. We might have some stuff there I need to clear out real quick. And when I type it in, I will, of course, have my x squared. I believe it was a minus 6x plus 13. Let me double check. Yes. So this one comes nowhere close to hitting your axis. If you have your home zoom, it may not have even hit there. Zoom out, you can tell it's never going to make it down to the x-axis because it gets to about 4 and then it turns around and goes back up. So this does not have a real solution. If it doesn't have an x-intercept, it doesn't have a real number solution, but it probably will have a solution with an I in it. And that's another good use of the quadratic formula. Not only can it get you exact solutions when graphing might only get you decimal solutions, but it can also get you some real number some solutions that are not real numbers, they're complex numbers. Now, let's go ahead and try your quadratic formula. So here we go. Negative b is going to be negative 6 plus or minus b squared. Once again, that's going to be negative 6 squared, but a negative squared is a positive anyway, so I'm only going to write down the 6 squared minus 4 times a times c all over 2 times a. So a negative 6 is a 6. Plus or minus, I need to simplify what's in that side of the square root, and I'm going to go ahead and say 2 times 1 is 2. But we need to simplify what's inside the square root. Once again, do not type the square root in, just what's inside of it. So 6 squared minus 4 times 1 times 13. And I can see what my problem is. I actually have a negative 16. The number inside the square root was a negative this time, and that's why it is not going to be a real number solution. Because you might recall from Math 2, anytime you have a negative inside the square root, you're going to end up with a I. So that negative inside the square root means that this is the same thing, I'll just write it above it, as I square root of 16. So that's going to be I square root of 16. And the square root of 16 is 4. So that's going to be, it's the same thing as 6 plus or minus 4i over 2. Now I need to go ahead and reduce. So I need to say what divides into all of these? Well, what divides into 6, 4, and 2. The I being there doesn't change the need to reduce those numbers if I can. And that's going to give me a final answer of 3 plus or minus 2 I all over 1. And if you don't want to put over 1, that's fine. 3 plus or minus 2i would be the correct solution. Now, one thing worth mentioning is this 3 plus 2i is ugly, but it actually really is a solution. If you were to substitute in the 3 plus 2i into my original equation, so if I was going to put a 3 plus 2i where the x was and check it by doing a 3 plus 2i squared, and say it equals 6 times 3 plus 2i, and notice I put in the same solution with a plus on both sides. I do not put a plus on one side and a minus on the other side. I put the pluses on both sides. I could simplify that, and after a little bit of work, you would find out that those actually algebraically came out to be the exact same thing. If you recall that an I squared is going to be negative 1. So I hope this helps you to understand how you can get complex numbers with quadratic formula.